Okay, so we're going to go through how to do more complicated equations and problems with rice. And I'm just going to go through three basic ones. But you can get very, very complicated equations where you're basically changing things all over the place in these different areas. Now, some teachers don't teach rice, they teach ice. I like to do the R because sometimes the reactions aren't balanced, and that'll kind of cue to you. Even if they are balanced, some students might not write the numbers in the right place and do the right conversions. So it's all about formula setting out in units, making sure you get it correct and get the right answer in the end. So follow it out exactly as I model it for you in these PowerPoints. The second thing is I put a lot of assumptions in this one, and I'm only going through three. I'm not putting more difficult ones in at this stage, okay? So this one here, the other assumption is it's all homogeneous. Your syllabus says they're only going to test you for homogeneous and not going to use the too difficult algebraic equations. You don't have to do the quadratic expression. So there will be X's though. So this one here, 1 mole of iodine was reacted and only 0.02 was detected at equilibrium. So this is how I write it out. So normally I just put lines underneath following through lines from here to save on that. But I rewrite the 112 in. Okay, and now the question said there was 0.01 mole of iodine. Now these are concentrations. So the first assumption is we're just going to make this or 1 liter. And the second assumption is there's excess iodine, or iodine is exactly the same. And of course, the other assumption is you're starting at nothing and you're moving into products. And then that's from the equation. So test resilience, sometimes things are assumed, sometimes things are forgotten. You're expected to get to that stage from a poorly worded question, okay? Just in case it's not worded greatly. Okay, now we're going to move through and actually solve this little Sudoku problem here, and then we can do the expression and get the answer. So we got those numbers already. Okay, so what's going on? If it has gone from this to this, then this must have happened. It must have lost 0.08. Okay, and because of the reaction stoichiometry, that will happen to the other thing as well, and then these two will add up and this will increase by double because it's 1:1:2. So then you can work your way down and get that, which is the same as that. I've lost a sig fig, but whatever. And then you've got that. Okay, so now the equilibrium expression, products, that gives 2, so put that to a power of 2, sub in those numbers here, and then you get your number. So the answer is 64. Now the second one is going to be starting to use the X's. And so we've got 0.2, so we'll do the reaction stoichiometry, put the 0.2 of iodine, it's assumed this one as well, and the rest we don't know. Okay, so we do know the final number. And so we assume, if I just rewrite those again, we have to do X's now. So we know that's going to go down by the same X, and that one's going to go up by an X, 2 X's. Now try and avoid fractions. So if that was, just try and make them whole numbers if you need to times everything by 2. And so you get these values here. Okay, so same equilibrium expression, sub the numbers in, and that's it there. Now you'll find that for the ones they give you, you can solve for X fairly easily. The X's will cancel out. So you can just stop and work that through yourself and see if you get to the same number. Okay, and so the final answer is this. Okay, so we're going to now move into, and it's, oh, hang on, what have we got? Oh, and the HI I didn't work out as well. So 0.2 minus that number, and then 2 times 0.2. 2 times this number. Okay, don't forget to do the final thing. I think that's what the question was asking. I lost what the question was. Find the final concentration of HI. So it didn't ask for the other two, but I gave it anyway. Okay, last one is a little bit of a trick. When the Kc is very, very small, it's insignificant and you can get rid of it. Okay, so same deal. Make sure your stoichiometry numbers are in. Type in all the numbers that you have. You've got that one as well. assumed it's 0. So then we're doing the x's, minus x plus 2x. So we got this, this, and this. Now you have to write the assumption in, it'll be worth a mark. So I've got all that in there. All right, so I've subbed all that and I can get rid of these x's here. So write in this assumption that Kc is very small, so initial concentration is the same as final concentration, therefore I can get rid of the x's. You might be able to write it in less words than that, but it must be stated. And from there on, it's just solving for x. So have a go at a lot of those problems and all different types, and maybe even challenge yourself to the really difficult ones where they're changing x's in funny ways in different places in the Rice diagram.